Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
Go above and beyond.
they become very good at what they do, but only
0.1%.
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
With Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius podcast, now part of the Finding Genius Foundation. My guest today is Chris Peng. He's the co-founder and CEO of Labfront. It's a startup working to revolutionize health research by helping academic researchers efficiently collect and analyze biomarker data from consumer wearables. You know, I'm sure people have seen like continuous glucose monitors and Oura Ring and Fitbit and et cetera, et cetera, et cetera. So we're going to get into that. Welcome, Chris. Thanks for coming.
Thank you for having me.
Tell me a bit about your background first. Like, how did you get into this space? You know, what were you doing before?
Yeah, so my journey into this really started basically as a young child. My dad is a researcher. He was the former head of the Center for Dynamical Biomarkers at Beth Israel, so Harvard Medical School. And I spent my time all around labs and research labs and health space. And one of the main issues I saw was that we really don't have this healthcare system, right? It's more of a sick care system. You probably keep hearing this all the time, but you know, we have a broken healthcare system, and a lot of the things that actually could be saving us and helping us are in research and development and actually are published, but there's just no way to get it to the consumers. And so from myself realizing that there's this huge gap in between where research is and the actual medical applications, that's where I saw, that's kind of where we can make the biggest impact. And so when we started from that direction, we ended up moving slowly into the actual academic health space, realizing that, you know, to the medical system itself it's kind of broken. It's hard to fix directly, so you have to circumvent it and maybe trickle in from the side. But my personal background is electrical engineering, and I dropped out. I went to school at McGill. I dropped out in my 4th year, tried to spend some time figuring out what I wanted to do. Lived in Thailand as a volunteer, worked on a tricorder X Prize competition. Was part of UCC.
It was like Peter Diamandis and the X Prize.
That was, yeah, exactly. So that was one of their earlier X Prizes. Qualcomm Tricorder X Prize was a $10 million prize. Back then, $10 million was a lot.
Yeah, if you don't mind, I'd like to ask you a couple questions about that, because I saw that announcement years ago. So that's really cool that you participated in it. If you don't mind, maybe a couple of cool things that came of it.
Definitely. So basically, the competition itself, for everyone that doesn't know, is inspired by Star Trek. In Star Trek, Bones, McCoy, uses a device called the tricorder. And the medical tricorder was basically this small diagnostic, looked like a handset. This is a long time ago. And as they were able to diagnose any type of disease and also help treatment with this like little mobile-sized device. And so the idea, it was inspired by that to create a medical device that was able to diagnose 12, and they picked 12 very different, completely different diseases. So it had things like sleep apnea, it had atrial fibrillation, it had skin cancer, ear infection, iron deficiency. So they basically picked the gambit on all these different things, so it could model the idea that this could be extended to diagnose and treat hundreds, if not thousands, of diseases. So that was the competition. And at that time, I joined HTC, which was sponsoring, actually my dad bid into this competition, and my dad representing the Center Center for Dynamical Biomarkers. Our group basically consisted of both academic researchers and also industry consumer tech specialists. And we were using a lot of the technology available at that time. And this was, still the early days of wearables. This is the competition, I think, started around 2012. I joined around 2013. And basically using the sensors that they could capture the data to do automatic decision trees, diagnosis, and very light AI. And basically from that experience, we ended up finishing as one of the finalists, second place. And really what we learned was all this technology is already available, but there's just very few systems that bring it all together. And there was a lot of potential. And so we were very excited actually back then to actually make this mass scale and launch it. Unfortunately, the actual business of doing that, requires large amounts of capital and also an investment that probably wouldn't pay off for long terms. But that actually kind of started to shape how I kind of saw a lot of the problems that we need to solve, which is why, I started approaching this problem within research, which is most of these problems that really need solving require such a long timeline that most businesses aren't really willing to invest in it. But if you look at the long term, value creation, there is a very sustainable, very powerful business there, but you just need to have the grit to persevere in that space.
Okay. So that's what inspired you to co-found Labfront, is the tricorder. Maybe it was too ambitious or whatever it may be, but I now have a feel for how to do this, so I'm going to tackle it.
Exactly. A lot of the things that we saw was that hardware was getting better and better, but the software infrastructure that linked everything together was actually missing layers. So, you have your Oura rings, they're, great products. You have your Dexcoms, another great product. You have your Garments, but nothing really brings that all together and looks at it contextually from the lens of all sensors, right? So, Oura's focused on the data they get, Dexcom is focused on the glucose side, and everyone's kind of looking in their own silo, but actually a lot of times diseases are hidden in between these silos, right? They're the things between that define our health. So that's kind of where we first understood this is something really important. This infrastructure was really important, but then actually trying to do it directly, it's really hard to make a healthcare business or any kind of, because it's all about reimbursements. It's all about fitting into the existing system. So we did try out something in 2019 to try to directly approach something, built a sleep solution. I still think it's a very viable product, but back then, that was pre-COVID-19. The investors I were going to said that, there's no way anyone's going to do telemedicine. Telemedicine is not a thing. Obviously, we know that changed with COVID, but we were a little bit, I guess, too early, and the product itself was a little bit, to break into the system, it was a little bit difficult. So what we ended up realizing is we needed to find something that had a direct value to their customers, because in the end, most times consumers in healthcare systems, they don't actually pay it, right? So it's the insurance companies that pay. So it's one of those dynamics where you can serve the customer great, but the person actually footing the bill might not care or might not really willing to pay. So that kind of brought us eventually to Labfront, which is a solution directly aimed at the research side, where we could help academics basically 10x their workflows, make it a lot easier to collect data, analyze data, manage the data, the project, the research project, all in one place, offering them a solution at the same time being able to actually slowly make a difference and helping the entire establishment understand more about the digital biomarkers and our human physiology.
So what is the flagship product or the first product of Labfront that's the furthest along? What does it do?
Yeah, so basically it's a research management solution. So what it does is, imagine you're running a clinical trial or you're running any type of research project, right? So any time the audience has heard, caffeine is good for you, or red wine is good for you, or this is bad for you. There was some kind of study, not necessarily a clinical trial, but some kind of study that looked into this information, right? And then so we basically make the software to help you manage that study. So if you're doing a study like that, it could be maybe 50 people, 50 participants that you're asking them to, do different tasks. It could be hundreds or even thousands of participants. How do you kind of manage that in a kind of cost-efficient way? So currently for clinical trials, even today, a lot of clinical trials are done very much manually by hand. Again, there's lots of money going to pharmaceuticals and they can pay for some of these things, but it's very ineffective, right? It's very inefficient. There's essentially research assistants that are just calling people up every day. I'm like, hey, did you take your medication yet? Did you take your medication yet? Just to ensure adherence. Labfront, what we do is we help researchers create an app. This completely no code, so they just go inside. It's like building a website. They build a little app, and that app is designed for their project. So what they want the participants to do at home. So, they could be taking medication, it could be doing yoga, it can be, measuring whatever. And we link it with wearable devices. So the current devices that we support and our partners are Garmin, Dexcom, and MoveSense. And we have a few more coming soon, and I can't really announce yet, but basically continuous glucose. Garmin has blood pressure as well as a smart scale, as long as obviously everyone knows about their fitness trackers wearables. On their side, MoveSense has an ECG and an IMU sensor, so there's movement sensor. So basically, we can capture all this different information from devices and then automatically transfer that for the researchers so they can see it. So basically, abstract the entire layer of, managing this process, reminders, all those things, and basically get it to the point where the data is in your system. And then what we're building is the analysis engine. So not only can you collect this data, manage this data, but also you can analyze it directly within Labfront. Because what we found is the majority of researchers, especially when they're starting out in their careers, they just have too many things they need to do, right? They need to, they need to teach courses. They might be clinicians, practicing. They might be...
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
What's the problem in a clinical trial? Let's say I got 50 people or 100 people in the cohort. They got wearables. What else is needed now? What's so hard about it? They've got wearables, let's say.
Yeah, so in general, for a clinical trial, it's just getting the data itself is kind of a small pain. And the issues that we're seeing right now is everyone kind of has their own solution and essentially their solution works for their specific use case. In clinical trials in general, which is a smaller percentage of our audience, most of our customers are actually on the epidemiological trial, large cohorts, they're managing these people, and they don't necessarily have a lot of budget per person, but they still are doing very, very important research. That side of things, when they're running with a smaller budget, that's where our real advantage comes in, because we can essentially abstract away, the need to hire research assistants and the need to hire data scientists. So I would focus on that side, because I think as much as important as clinical trials are, there are already a lot of people working in that space, versus on the other side of academic research, the psychology, the physiology studies, the sports science, those things right now, they get a lot less industry attention, a lot less industry funding, and they're the ones that are struggling the most.
So what are the particulars that make, the current devices not useful for other clinical trials? Like, what is it about yours that makes it modular, where different use cases can use it where other ones can't?
Yeah, so that kind of comes to the way that we collect and analyze a data layer. So essentially, if you just take the data as it is, so let's take Garmin, for example. If you're not an expert in understanding wearable data, the physiology, then let's say you want something like approximating stress, right? You can approximate stress through heart rate variability. However, you also need to know that heart rate variability, when you're capturing, it captures beat to beat interval. So each individual beat of the heart, when it's done on a wrist, which is with a PPG sensor, depending on the different things that are happening, there's more or less noise, which makes that, that signal less or more or less, reliable. And that depends on understanding, the context of what you're studying. So some things it doesn't really matter, some things it does. So for us, what we do is we kind of take the entire, all that guesswork out of it, because we, been working in this for a long time. So I mentioned my father was the co-director of the Center for Dynamical Biomarkers. So they were working with wearables, for the last 30 years, back when wearables were backpacks. They weren't very much wearables. They were just computers that you could wear. And so that accumulated experience helps us understand what you need, and just completely, like, you click a button and you get the data that you want and you remove the data that you can't use based off of your use case. So that itself is an expertise and the skill that it takes. I won't say it's impossible. It's definitely not impossible. It's just a lot of time involved. So if we can just completely remove that, that saves researchers a ton of time, a ton of learning, and they can just get what they actually focus on. If they're a psychology researcher, they don't want to have to learn about the physiology of, heart rate variability / the sensor dynamics of these, engineering terminology and skills to do their psychology research. So that's kind of what we offer.
Okay. I mean, what have the researchers told you? Like, has this been used on, various research projects? And do they get the funding to work with you by, in the grant application itself? Like, let's say they're applying to the, NIH. Is there a provision in the grant where they include, let's say, your fees for your technology?
Yeah, that's a great question. So we've been around since 2021. We have over 100 research partners. So institutional partners from over 1,000 researchers. So that's institutions that most you will heard of, Stanford, Harvard, MIT. They're all research collaborators. The funding side is a little bit tricky because we replace multiple parts of the system that they have. But so the issue that we run into right now is that the researchers don't necessarily know the solution exists, and they don't necessarily know what part of the budget it should come from. And so what we really do is we kind of make their research assistants much, much, much more powerful, because they are essentially able to do a lot more and automate a lot more things. And then we also remove the need for a lot of research projects to have a data scientist on the team, which is a big part of the budget. So, but however, that is a little bit tricky sometimes when you're writing these grants, because essentially this kind of data science as a service, or these kind of like fractional services, fractional data scientists, is not something that traditionally has been seen from the perspective as a software service, even though the way they've done before is essentially, we'll try to get like 30% of this, this professor's time because he's an expert in this. That's how it would translate from the traditional system.
Why wouldn't you need a data scientist? Do you have like a statistical fractional experiment design on board with your system, to help the researchers actually, again, know how big the cohort has to be and what data they collect. So again, it's fractional and it's not too much effort.
Exactly. We instead of what we realized is that for the most part, a lot of studies can be simplified in terms of looking at what they actually need to see. So for example, if you have a study that has different groups, like your intervention group, a control group, placebo group, it's always good to kind of look through that and compare that to make sure you have a statistical significant and, a complete and diverse sample, right? So you want to just make sure there's no outliers within there, or there's limited outliers, and then the majority are, was basically normalized before you actually run the research. And so things like that can be automated. The process can be automated. And then what we've also found that is like for many studies, they're looking at, I have this intervention. I want to look at before and after this intervention. Okay, so that can be automated. We just basically within Labfront, you have a marker when the intervention, when something happens, and then you just compare the data before and after. Or you have something that's continuous, right? You're taking this, you're doing this meditation over six weeks. Okay, so let's look at the slope of change over whatever variable that you're interested in looking at. And instead of a researcher looking at it one by one, calculating it, doing all the work to figure it out, within one click, we can run it across all variables and then look at and tell you, these are the ones that are interesting, or these are the ones have some, these are have good p-values in terms of, there's some, some very, very clear changes. Take a look, highlight it, and then let them decide which ones to use. Like, we don't decide for them, but we just do a lot of the grunt work. So that makes it a system for them that they can just click around and figure out, okay, this is what I need to do. This is what I need to look into more. And, basically it does remove a lot of the work that the data scientist or the engineer usually does.
Are there situations where they require like a neutral third party to keep custody of the data so they can't, fudge the experiments? And I don't know if there's any grants that stipulate that, but could your technology be used in that kind of role as like a compliance type thing, or a data backup as well as collection?
Yeah, it's a great time to talk about this, especially in light of there's been quite a few academic research scandals in the past couple years where there have been people fudging data, and very prominent researchers fudging data, and that is a real problem. And it's a real problem that if you have a auditable a data trail, which we do within Labfront, it makes it a lot harder to do this. So basically, there's also been a movement from the NIH that I think is called the Data Management and Sharing, a provision where they want researchers to actually share their data, at least have a way for peer reviewers to actually figure. That's basically reverse engineer, like retest out this study, as well as letting other people have access to be able to build upon it themselves. So we built Labfront in mind with the future, which is we think is a much more open, much more sharing, much more collaborative future. That's what we hope for. And so, partially, yes, it will affect, we can kind of mitigate some a lot more of the the fudging of data. Essentially, like we can tell exactly if there's been changes, and it's a lot harder to mess with Labfront data instead of just adjusting an Excel sheet, which was what was done in a lot of these cases. They would have to create accounts, sign fake informed consent. They basically need to create fake participants. And when it makes it really difficult to kind of change your stuff, that's what we see the deterrent. It's when it's too easy and it's like, oh, you just change one number here and everything's fine. That's when we see like what happens in this is a very cutthroat academic world. We have to recognize that, they have these pressures. So if we kind of just make it a little bit easier for them to keep their academic rigor, it'll go a long way to just incentivizing the behavior we want.
What about the speed of analysis? Budgets are always a concern. If your tool is able to very early on detect true signal versus no signal, maybe you abandon a test and don't go all the way, and it saves you money because it has no significance to it. Maybe you end the test early because it has an incredibly strong signal. Is there any of that's packaged in your analytics pack that would help?
Yeah, so that's so part of our direction, and I think you're onto a really good point, which is the future of research. Now, there are research studies, clinical trials. They have to be blinded, and they have to run their course before they look at the data to make sure there's no bias. But then there's other studies that you're essentially just like observing, and if you're observing, you as you learn more, you can add more markers into your observation that you maybe did not plan for in the beginning. And in the traditional way, it's really hard to do that, right? It's like you have to completely change your protocols. You need to update participants what they need to do, and it makes it kind of difficult to kind of run this kind of live project and learn from it and iterate while you're doing it, which makes it very inefficient. Labfront, we kind of work towards that direction of the future where you are kind of analyzing your data while you're going along, right? So you're looking at this and you realize that, oh, I'm really there's some interesting thing happening with sleep, but sleep was never the focus of this study, and I didn't put enough markers into sleep. So maybe I'll add another questionnaire here, or I'll just turn up the frequency for some of the data collection, or maybe I'll add a sleep test, and you can do that automatically within Labfront without basically doing anything. And the participants themselves, they just get an update and they say, oh, you got a couple new tasks you need to do. Small things have changed, not a big deal. Here's what you need to do now for this week. And so kind of going along the lines of a living project, a project that's continuously iterating. We were kind of seeing this like continuous iteration direction, and essentially for projects like large generational studies like the Framingham study, this would be very useful for they can keep like every 6 months they could add a new biomarker or reduce one or change one, or add some more metrics to kind of study something different or study something more. And so that's kind of it's already built in because it's very simple to execute something like that. Right now it's more that most researchers aren't doing that because it has been so difficult to analyze data. So you mentioned before the data analysis and the time. There's basically 50% of the time that researchers spending from the data analysis are just getting all the data into one place, because again, a lot of times they're coming from different sources. I mean, if they just want to align the timestamps, like if you're not a proficient coder, that's a lot of time. And on top of that, analyzing each individual data point and then visualizing them as well. These are all things that need to be built on an individual basis for researchers. And so by abstracting all that away, we basically save that first, most difficult, as in most time consuming, but actually just mostly tedious work that researchers used to have to do.
What about on, once a study has started, I have heard people drop out, they just stop cooperating or, whatever happens to them. Is there a way to put something into the analytics package where, let's say you have a cohort of 100 and you're allowing for, a 10% dropout, but now throughout the study, it's a 6-month study, you're in month 3, you've had 8 drop out, now you're getting to a danger zone where the study could lose a statistical significance of too many more drop out. Are you able to monitor things kind of in real time as it goes to see if the statistics are holding or, other problems are creeping in?
Yes, we are. That's exactly what we basically provide. I think the problem with dropouts is it basically comes down to adherence and motivation. And so what we've seen is that, we can let you know in real time if your project is hitting the danger zone, but that's less useful because there's limited things that you can do. On the other side, the practical things that we have been able to help researchers with are essentially setting up your studies in ways that we've seen so many research projects. We've run so many of these projects, even if they're run through our partners, we've been a part of the process. And so there's lots of things that can be done to help incentivize, help keep the participants engaged. There's a balance in terms of how tedious your tasks need to be. Maybe you front load a lot of things, right? You get a baseline, you front load a bunch of things. And so you do all your most tedious things in the beginning. And then after that, it's mostly passive data collection. And then at the end, you want to do a baseline again. Then at the end, not only do you have it, you also have the reward, and then potentially you also give them a report at the end as well. So there's a lot of small things that can be done to optimize and bring in more value to the participants and make it less about them just being a passive participant and them being more like an active, interested party, which very does wonders for motivation and does wonders for adherence as well.
What about in the building of a study? If someone's trying to achieve a certain p-value and they expect a certain variation in these, variables that are being tested, could your modeling pick out, all right, to really round out this cohort and make sure that you're within, you're going to get the right data, you're looking for this, that, or the other in 5 more additional people that you want to subscribe to the study? Is there any way to do that where, again, you're helping in the initial shaping as well?
So 2 parts to this question. So right now, that's not something that we do in terms of the early stage of this is basically in the recruitment stage, but actually in the next 6 months, we're gonna release some stuff related to this, which is basically want to take we're looking at the entire research flow from initial recruitment all the way to final paper publication and see all the steps in there that we can basically support or be the one-stop shop to kind of solve these problems. So in about 6 months, we will have more definitive updates in terms of exactly what we're doing on patient recruitment side. But suffice it to say, after, having over 100,000 participants join Labfront research projects, and a lot of them interested in joining other research projects, we do have some, let's say, unique expertise and some customer base to build that off of. And so eventually I do see Labfront as a solution that really starts from the very beginning of the research cycle all the way to the research publication, and then also having some stuff for around funding as well, being able to generate revenue off of research funding, but off of the research that you do. But what you're talking about right now in terms of supporting them in this space, they're limited. However, the second part of your question, or the other ways that I understood it was, there is a potential to, if you know what you're looking for, to set that up within Labfront in a way that you can directly, very quickly see if there's results already. So if there's not enough results or there's not enough users and you're finding out about that 2-3 weeks into the study because you realize, I need more data points, or I need more, either, the users are too similar or the data that we're getting is too similar. If we just, double the amount of users, we would know that pretty quickly. So you basically can, do another batch of recruitment, and you wouldn't have to find out about this at the end. And that's really the biggest problem, which is that you find out at the end and it's already too late. The time has passed, the budget has been spent, you've been allocated, and then you end up with a result that it's harder to publish, and that's a downhill spiral. So by knowing about it earlier, we still believe that would still have an advantage, and so that's kind of another advantage that we provide at Labfront.
Are there grand situations, I don't know if NIH does this or private funding, whatever, but if you achieve certain either milestones or you provide X amount of data, they release funding for the next step. So if you're able to speed up the process so the data gets back to the potential funders quicker, I guess they could get the funding quicker and the whole thing can move faster. Is that part of the software?
So there are those types of projects like, for example, SBIR that release in phases. The majority of the projects that we work with are essentially just one lump sum. There, again, we focus on the earlier career. Again, we think that the biggest challenges are for the early career researchers, and then that's what's causing a lot of them to drop out of the system is funding challenges, fundraising challenges, and then, the challenges of actually running a study as novel and new as one of your first research projects, right? That's basically what you're expected to do as a researcher. And it's not, we think it's not, that's pretty difficult, but we want to support them in any way we can because we don't want them dropping out from the industry and going into other places. So we think that's the kind of brain drain that we're trying to avoid. Now, to address the second, I think you're talking about funding. That is a major problem within research in general, and maybe I can answer it this way, which is there's a lot of problems right now with the way that funding is allocated and distributed, and making it really difficult for a lot of researchers to, basically have consistent funding. Even if you are, we work with top researchers, right? We work with some of these, they have, tens of thousands, hundreds of thousands of citations. It's still a guessing game for them when they get their funding. Now, their funding amounts are usually larger, but it's the same thing. They spend a lot of time on fundraising. And so one of the things that we've been building in, and this is where the future that we believe the future lies, is having ways for researchers to actually directly monetize some of their research or to get some value out of the research that they create. Because right now, essentially, the only way for a researcher to really make significant money or even enough money to fund their research sustainably is essentially to, as a researcher, you need to start a company, and then that company needs to be sold or IPO, which is a really arduous task that you're asking a researcher. They're, that's not their background. There's not an entrepreneur. And basically it only works for a very small segment of researchers because only a small segment have research that can directly be monetized into something like that. So maybe like drug discovery, for example. On the other hand, a lot of times researchers are doing very important and useful things, and it's proven by the citations that they have, right? Other researchers are citing their work and saying, oh, this was really useful, and so that I'm copying or I'm mimicking, they're using their analysis or their methods and building upon it, right? That's how the citation system works. But right now, how it works, is essentially I, as a researcher, if I read this paper, I found this amazing paper, and by this other researcher, and then I try to understand their method, and then I try to recreate it and reverse engineer and recreate it from scratch. They do write it out, and that's the whole point, but it's still difficult, especially if I'm not necessarily, the most experienced in this specific thing. Even though I want to use it, I thought, oh, this is very interesting. I want to utilize this heart rate variability or this nonlinear heart rate variability measurement, but I'm not a specialty. This is not my specialty. I'm focused on the psychology side, or I'm focused on the physiology side. It becomes a big barrier. So within Labfront and what we're building in the coming year is a platform where it allows researchers to, if they've already created the analysis and they wrote the paper on it, instead of making everyone have to try to figure it out themselves and waste a bunch of time, they can build basically like a little app, basically an algorithmic app that just does what, some of the work within the paper does. So when other researchers want to utilize it, they can just input the data, and then the output is the result that what they were actually looking for, the results of that the paper was showing. And then so essentially, instead of building it themselves, these other researchers can just pay a small nominal fee to the original researcher that created it, and they can save literally days of time, weeks of time, and get a solution that's very simple. And that way, we basically can start to create the process where the more papers that you write, the more citations that you have, essentially can also mean that your earning potential increases. And so the idea is that over time, as more researchers utilize your work, you get to a point in your career that essentially you maybe don't need to spend 50% of your time on fundraising, which is what even mature tenured professors, researchers still do to this day. Yeah. So essentially changing that entire dynamic to a point where there's a way for them to actually monetize directly, with the work that they're already doing.
Well, what if I'm doing a study and I'm picking up data on 5 different biomarkers that are not part of my study, but I got them. And then I want to monetize that for other researchers. Is there, what if you do studies and you make them amenable to a meta study later on? You put them all into a platform, you get agreements, and then researchers can look, let's say again, I'm just making this up, they're researching blood glucose, and they can see, all these other studies were done, and they might have data that we could use. Maybe we can contact them and pay them a little bit for the data they're not using and use that for ourselves and vice versa. So maybe a study could earn some more money from the data that they're collecting by happenstance but not using. And again, make a meta study more amenable later on.
Definitely. This is also, part of this entire data sharing, data licensing kind of concept. So that's also another part of that we're working on as well. And you're touching on a lot of things that can make the research system a lot better. The issues that we run into right now are just, there's a mindset issue right now, which with researchers are very protective of their data based around the way that, essentially the attribution of work and, the getting, the proper, the credit for doing that study, right? So there's a lot of, the system that we have right now incentivizes this kind of zero-sum competitive approach versus if they were able to kind of change that a little bit, then there would be a lot more appetite for data sharing or even data licensing. Now, our approach is focusing more on the ownership of the actual participants themselves, because participants, they are generating this data, so they automatically by default have some rights to the data, definitely to the data they generate, not necessarily to the data in that research project because there's other things that are happening, but for the data that they generate themselves, they definitely have rights to that. They're literally the data originators. So we've been thinking about how do we create a system that allows those participants to essentially, join another project while and then essentially licensing their data again for multiple use cases. So they've already collected it for this, and while they're at it, they also collected a bunch of other data, that was collected on their Garmin, Dexcom, and whatever. And it also fits another study, right? There's another study that fits exactly this, but they just want, they're missing a blood test. Well, if they can just add on a blood test, you have now meet the requirements to fulfill all the data that's needed for that study. That is a lot cheaper than doing the entire study from scratch. So there's a lot of things around there with a research participation gig economy potentially, and data sharing and privacy that I'm very interested in exploring further. But the issues around privacy are very important. So I've been working with different groups, including I just had a discussion with Oasis Labs based out of San Francisco, where they have these privacy protecting ways of essentially sharing information, sharing results of information.
Pseudonymizing it or something?
Exactly. There's different methods such as fully homomorphic encryption, FAG, or, ZK, zero knowledge. So potentially there's ways that you can actually license your information or the results of your information away without actually exposing the data that you have. And so there are some very interesting things there that essentially let you potentially in the future, very future date, you can infinitely sell your data but actually not for different specific research use cases without ever actually exposing the actual raw data itself. So you can get results of the information without actually giving up the actual information. And in that case, then you can actually control a lot of different things about, in terms of your privacy and making sure that, and it makes it a lot easier for people to decide that, this is something I want to do, because essentially that data cannot be traced back to you in the sense of de-anonymizing yourself.
All right. Well, last question. Anecdotal evidence is demonized. So you may have a clinical trial of a cohort of 100 people, but then millions of people may take the drug that you create. And wouldn't it be amazing to get the data from those people? Millions of people taking your drug, let's say, young, old, men, women, this, that, the other, all kinds of conditions. That would really help round out the effects of your drug. I mean, you could do a lot of tweaking, I don't even know. It would suggest a whole bunch of things. Do any researchers do that? And could you interface with them to then, again, once it's been commercialized, get all that anecdotal data and then put that back into the system to create better products?
Yeah, so I'm not aware of the research that are currently working on this problem. I think the issues that they're seeing right now is just the incentive models around it, right? So it's essentially a system where, no news could be bad news, and in that case, I don't want to know it kind of situation. If you pass the FDA, this is done, then essentially you don't want to really rehash that problem. And I think this is an incentive problem that can be addressed. But I definitely think this is the direction we want to go, right? Which is that these things, sure, we've done a clinical trial, but a clinical trial, again, doesn't necessarily cover, it's not all the data possible. And if there's more data coming in, and there's obviously going to be fewer ways to utilize this, whatever intervention, this could be a drug, it could be anything, and figuring out what's the most effective way to utilize it, right? And all that information right now is essentially lost in the ether. A lot of times it's not collected, and it's really hard to utilize it, even if it was. And so our kind of long-term vision is that people, with a lot of the stuff that we mentioned today, have more of a hold on their data and their data rights, and, can kind of have that as a fundamental part of, maybe this health passport, where they themselves have control over these things, and they have a way to manage and collect this information. And then once you can solve that part of the problem, then essentially the rest of it is kind of is much more easier to do. And so I think this is the direction that data is going, that research and health data should be going, which is that there should be more patient and personal privacy and personal rights to your data, more control, more understanding, and more ways to utilize.
All right, excellent. Well, Chris, what's the best way for people to find out more about Labfront and keep track of what you're doing?
Yeah, so if you're a researcher and you're interested in using Labfront, just check us out at labfront.com. We also have social media profiles as well on Facebook and LinkedIn and Twitter. And then if you're actually interested in being a part of a project, so we will be starting something soon. So just follow our socials where we can allow people to, join really interesting cutting edge research projects. We'll be working with some very cool researchers in the space of psychedelics, especially for mental health. It's a bunch of stuff in the mental health space, some stuff in the meditation space, and actually many more other things as well. So if anyone's actually interested in being a part of a research project themselves, just follow along, and we'll have information about that coming soon.
All right, excellent. Well, Chris, it's been a great call. Sorry I questioned you to death, but hopefully I got some good info and food for thought. But thank you for coming on the podcast. I appreciate it.
Thank you so much, Richard. I loved your questions and can't wait for the audience to hear this.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.